today we start with chapter law of motion. In this chapter we discuss how Newton's law of motion play an important role in day-to-day life. We discuss here concept of inertia, motion, and Newton's law. Okay, so before we come to Newton's law, first we go to inertia. This is very important term, inertia. In theory classes we have already studied about the inertia. Inertia means it is an inherent property of an object. This states that any object cannot change of its position by itself. So no one object in the universe cannot change its position by itself. That means we required some force in order to change its state, either in direction. Okay, so there must be some force we required. So inertia means any object cannot change of its position by itself or own. Okay. So in order to understand the concept of inertia, momentum, scientist Newton discovered law of motion. And in law of motion, so this law of motion study in three parts. Number one, law of inertia. Second one, law of force, or we can say momentum. And third one, law of action and reaction. So in this class we discussed all the three laws in brief. So first we take here law of inertia. So law of inertia is to be studied in three parts. Inertia is in rest. Second one, inertia is in motion. Third one, inertia is in direction. So inertia we have already discussed that any object cannot change of its position by itself. So this is to be add with rest position, then motion position, and then direction position. So if we talk about the inertia is in rest. So according to Newton's, if any object is in position of rest, okay, so it remains in the position of rest until or unless any external force is to be applied on it to change of its state. Okay, so any object which are placed in position of rest cannot be changed its position without some external force. That means we require some force in order to change its state or position. For example, this board. So this board is in position of rest. Okay, this is good example for in order to understand the concept of inertia in rest. Till we have to apply here external force to change of its position from this wall to another one wall. Okay. Second one, inertia is in motion. So according to Newton's, any object is in position of motion. So until it remains in the position of motion till an external force is to be applied on it to change of its state. Okay, so motion position remains same till external force is to be applied. So in day-to-day life we observe so many phenomena where we apply some force in order to stop the object. For example, if you roll down the ball on the floor, so this ball continuously is in motion. Okay, but due to frictional force, okay, so frictional force here play like a external force. So because of frictional force, the ball will be stopped. Okay. Similarly, in moving vehicle, when we apply a brake, so this brake is treated like an external force. Then a moving vehicle is to be stopped. Okay. Next we come to inertia is in direction. So inertia is in direction shows any object cannot change of its direction by itself. Again, we required some external force so that it becomes change the direction. And again we see there are so many examples like in cricket game. When a bowler throw the ball towards the batsman, so batsman change the direction of ball. Okay. So here external force is to be given by the batsman, either in left side, right side or straight. Similarly in moving vehicle, when a vehicle is to be moved on a straight road, okay, so we change the direction accordingly. So we change the direction. So this is the first law. This states that we required external force in order to rest motion or change the direction. That means force play an important role. Second, according to second law of motion, the rate of change of momentum. So here we use the word momentum. So first we see what is momentum. Momentum is to be denoted by a P symbol, and this is the equal of mass into velocity. That means whenever any object have mass and it has some velocity, so definitely it has some momentum. If we talk about the unit part, so mass is kilogram and velocity is in meter per second. So the unit of momentum is kilogram into meter per second. Now we come to second law. So second law states that the rate of change of momentum is directly proportional to external force. For example, if an object go from initial to final position by applying some external force, okay, it changed its position initial I to F. So initial momentum, this is to be Pi, and final momentum is to be represented by Pf. So according to this law, the rate of change of momentum, that means final momentum minus initial divided by time, is directly proportional to external force, that is F. So this is also written as Pf minus Pi, that is change in momentum. So this is to be denoted by del P. Del what means here difference, small difference, with del T, and this equals to external force F. Here constant K having value 1. So F is equals to dP upon dt. Okay, and from this we also find the force, because as we know force is equal to mass into acceleration. So if we go in differentiation form, that is dP by dt, and we know momentum is equals to mass into velocity. So if we replace d by dt, mass into velocity. So mass is always constant, so mass is outside the differentiation, remaining is dv by dt. This is rate of change of velocity, this equals to force. So this equals to mass into acceleration. So Newton's second law also define force. Force is equal to mass into acceleration. Okay. Next we come to last one law, law of action and reaction. Law of action and reaction. So this third law of Newton's state that whenever there is an action, there must be reaction in equal amount. So every action have equal and opposite reaction. Okay. And this is very important. Both action and reaction act on two different objects. So action and reaction act on two different objects, not in same. Okay. So we have seen in daily life so many examples when we walk. So when we walk on the road, so between front leg and back leg, action and reaction take place. Similarly, if suppose we take two objects M1 and M2 which are separated by a finite distance, so again from first to second object one force, this is F12. Similarly second to first one more force, this is F21. So F12 force, this equals to minus F21 force. This shows every action having equal and opposite reaction and both act on two different objects. So what we have to learn today? Today we discuss Newton's law of motion. In Newton's law of motion we categorize three parts: law of inertia, law of momentum, and action and reaction. Thank you.